separate network interface which should not do anything in terms of the private public communication. So ETH1 is the private interface communication. Now in Oracle, we still do not support the heterogeneous network interface names. It means if you have used ETH0 for public on node 1, the same ETH0 should be used on the other nodes also for public. You can't make ETH1 as private, ETH1 as public on the other node. At the moment, we are still not supporting it. So the private interface is basically going to be used for the private communication between node to node. That means some messages which are essential for nodes to work are going to be actually available through the private IPs or the private interconnect. This configuration is going to be always present. That means whichever 11.1, 11.2, 10.2, this is going to be always available to you. Now, in terms of the previous versions of RAC, only these two IPs were actually needed. So in the etc host file of both the nodes, one public, one private was actually used. Just last bit, since the public IP is used for outside world, the protocol used has to be a stateful protocol. So we use the TCP/IP protocol, for example, which is a stateful protocol to communicate with the rest of the world. The private communication between node to node has to be very fast, and that means we cannot afford to actually wait for any kind of acknowledgement or something. We use stateless protocol, which is, for example, can be UDP. UDP is a stateless protocol. UDP basically works as send and forget, which basically means you don't actually wait for the acknowledgement to come after sending a particular packet to the receiver, and that enhances the performance of your particular communication. Since this communication between node to node has to be very fast, UDP is basically recommended for the same purpose. So we basically have two nodes, and in terms of the client machine, so if there is a client machine, in the client tnsnames.ora, we put up in the address column the host 1 public IP, and host 2 public IP. So the client, it actually goes to the host 1, the client goes to the host 1, and the client actually finds out the particular information about the host IP, the listener running. So there is a listener which it will be started on each node. So there is going to be a listener which is available on each node. And obviously, we mentioned that there is going to be a database instance. So assuming our database name is ORCL, so we have ORCL1 and ORCL2 running on both the nodes. I think this particular setup should be fine for you. That means that you are trying to get connected in the tnsnames.ora. You have host 1 public IP, host 2 public IP. When you try to connect, you look for the first IP, you resolve the IP, and you come to the particular node. On the node, there is a listener running over there. The listener is listening for the database instance service, and finally you find the service and you get connected. Is it now? Let's suppose in RAC we basically talk about two things. One is called load balancing. In RAC we talk about two terms: load balancing and failover, right? Now, assumingly that my particular node 1 is going to be down. Now I need to failover. The problem with the setup that we have right now in front of us is that we are relying upon the TCP/IP protocol to get connected the client to the node. And TCP/IP is basically going to be a stateful protocol, plus it has to have certain number of retries and timeout needed before the client can be actually coming to know that the node is going to be down. So it means there is a timeout which is going to be required. Before that, the error message cannot reach to the client that the node is going to be down. Now, the timeout which we have configured in terms of TCP/IP is 10 minutes. That means till 10 minutes, the client will keep on trying to reconnect to the node 1. After 10 minutes only, the client will get the error message TNS lost contact, right? Or cannot resolve the host name or whatever. And then the client will initiate a failover. The failover will mean that the client will now read the second particular host 2 information, IP information, and the client is going to log in to the host number 2 or the node number 2. Obviously, there is a listener running, there is an instance running. The client can connect to the particular second instance. So this is how the failover used to happen before we made 10.2 as the uh, first one. Sorry, the what you say 10.2 as the default one. So I think the problem should be very clear to you that using the IP or just the IP, the failover takes much longer to happen, which is unacceptable when we talk about high availability concept, which is what the backbone of RAC is. I think should be fine. Is it? Now, obviously, this was not actually a very good solution. So we changed the particular rack environment and we introduced another configuration IP, which is what we call as the VIP, right? Now, the VIP, or also known as virtual IP, commonly known as VIP, is actually just another IP. It is not really anything special. It is just another IP which is running on the same public interface ETH0 on which your public IP is running. And VIP is available like IP on each node individually. So you have VIP1 and VIP2 running on both the nodes. And VIP1, since it's an IP available on the ETH0, your listener is available, or you can say listener is aware about both of your public IP as well as your VIP. That means the listener is actually knowing that it can listen to the public IP as well as to the VIP. VIP, besides being knowing in the client system, rather than using the host IP, right? You should be using what we say is VIP. Now, what is the benefit? The benefit is going to be that you are going to be having the VIP interface used for the connectivity. The VIP is going to be sent to the listener. Listener will connect you to the particular instance. In case of a failover, as I told you just now, VIP1 will be shifted to the node number 2. Now the trouble is VIP1 being shifted to node number 2 will actually cause the change of an address, which is the MAC address, which is appended on each VIP of the network interface. What I mean to say is when you start VIP1 on ETH0 of node 1, the ETH0 MAC address is appended with the VIP1. And when the VIP1 does the switchover to node number 2, the MAC address of the VIP1 is going to be the MAC address of the interface card on node number 2, which means a new MAC address is initiated. And this particular new MAC address initiation is immediately going to ask for the node number 2 to do something called REARC. REARC is a protocol which is actually the address resolution protocol. It means that next node, the node number 2, immediately broadcasts the VIP1's new MAC address to the all collected clients. Now all the connected clients, when they get the notification that the VIP1 is actually having a new MAC address, they immediately mark their connected sessions which are on node number 1 as invalid, and they try to reconnect to VIP1 on the other node. But the listener running on the other node does not listen to VIP1. It listens to the public IP and to the VIP2. Once the VIP1 is discarded by the listener running on listener 2 on the node 2, the client reads the second VIP address from its DNS names and connects to the the VIP2 on the second particular node. This is going to happen. This whole thing gets completed within 20 seconds time. That means in not more than 20 seconds, the client definitely will get the error message and will definitely connect to the next node. It means within 20 seconds, the client will initiate a failover as well as the client will get reconnected. Client will initiate a failover as well as the client will get reconnected to the other. This is basically what is happening from 10.2 as a mandatory setting. You cannot install RAC without having three IPs, one public, one private, and one VIP on each node. Is it clear?